Okay, the lesson that we're working on right now is lesson 8 on page 559. This is a big lesson because this lesson finishes off transformations. So once we finish lesson 8, we are done all of the transforming for trig. So just to quickly review what we did yesterday, at the top of your page, I want you to write y is equal to the sine of x. Okay. And then when we have y is equal to the sine of x, right now, there's an a value in here that's invisible, and that's the amplitude of your graph. So my a value is 1. The amplitude or the height of a sine graph goes from 1 to -1. Then there's a b value in here, and the b value is also 1. But what the b value does, it is a horizontal stretch, but it tells us the period of our graph. So we know that in order to figure out the period of a sine graph, the period is equal to 360 degrees divided by the absolute value of b. So 360 degrees divided by 1 is just 360 degrees. So sine graph, one complete period is 360 degrees, and then it repeats itself. So a sine graph, remember, always starts at 0. It's going to reach a max height of 1, min height of -1, and that's one complete period. Let's put the x-intercepts on our sine graph. So the x-intercepts are 360 degrees, 180 degrees, 0 degrees. And then if I put, like I said, this 1 in there, and -1. So this is a sine graph that hasn't underwent any transformations. And then what we did in the last lesson, lesson 7, is I introduced the a value, and I said, okay, if the a value is 5, what that does, it changes the amplitude to a height of 5. It's going to be a vertical stretch factor of 5. And then we changed the b value, and the b value would affect the period. So maybe instead of 360 degrees being the period, it might have been 180 degrees would be the sine wave. So that was the a value and the b parameter. Today what we're going to do is we're going to introduce the last two parameters, which are c and d. So we'll just write it for the sine graph, but remember that a is your vertical stretch and b is your horizontal stretch. A is also your amplitude, b is not the period, but you use b to determine period. C is going to be the horizontal translation. It's going to move your graph left or right. And D is the vertical translation. It is going to move your graph up or down. One last thing that I told you in lesson 7, whatever the D value is, that is the midline of your graph. So the D value is the midline. So if I went back to this graph up here, y is equal to the sine of x, and I said, well, what's the D value? Like, what's the invisible D value? It's 0. Yeah, the midline is 0, so the invisible D value would be 0. And then what's going to happen, like what we will see today, is let's say I give you y is equal to the sine of x plus 5. What you would say is you would say, okay, that's my D parameter. D is equal to 5. What that means is the midline is 5. So you would draw yourself a little Cartesian plane, and you would count up to 5. 1, 2, 3, 4, 5. That is your midline. And then this graph, what would the amplitude Kelly of this graph be? So what's the a value here? 1. So the a value is 1. That means that this graph has a height of 1. So it's going to go up to 6, and it would look like this. So the max of this graph would be at 6. What would the min of this graph be? At 4, right? Because 5 minus 1 is 4. So the range of this graph would be from 6, or from 4 to 6. So that's what happens with the midline of my graph. Class example 1. Describe how the graph of the given function compares to the graph of y is equal to sine of x, where x is in degrees. So you have to say to yourself, let's actually write the all of the parameters. So it's going to be y is equal to a sine, open bracket b, open bracket x minus c, close 2 brackets plus d. So you look at this, you compare it to the general form, and you say, okay, that would be a C value. The C value here would be 30 degrees, so it's always the opposite. Then you have to tell me, well, what is the C value? That's your left-right translation. So this would be a horizontal translation, 30 degrees right. The replacement for this would be an X replacement, and it would be X is replaced with X minus 30 degrees. For this one, this plus 2 is your D value. D is equal to 2. That moves your graph up or down, and it moves that midline up or down. So that would be a vertical translation, 2 units up. The replacement for this is a Y replacement, and the Y will always lie. So the replacement is Y is replaced with Y minus 2. See if you could write for 3, the C parameter below this, and the D parameter. What's each parameter? And then tell me in words what's happening. How are you going to describe that in words? This would be a C parameter of negative 60 degrees. And that would be a horizontal translation. Remember, we don't say negative 60 degrees. You tell me the direction, and that will take care of the negative. So horizontal translation, 60 degrees left, because it's negative. This -1 is not my K parameter anymore. In trig, that becomes my D parameter. So D is equal to -1, and that is a vertical translation, 1 unit, tell me the direction down. So you would never say to be -1 units down, right? You're moving 1 unit down. 2 parameters are happening here, so do the same thing, write both of these. So get that C value written and get that K, or it's not a K value, that's a D value. Kieran, what's your C value? What direction is it moving in?
Right.
That's right. So this would be horizontal translation, 45 degrees right. AJ, what would my D value be?
45.
It would be 45. And what would that be, AJ?
Vertical translation, 45 units up.
That's right. Vertical translation, 45 units, and then up. So the midline would be at 45, right? And the amplitude is only 1. So it's going to go, the max is going to go to 46, and the min is going to go to 44. What I want you to now highlight, highlight this. So we change some of the, what we call things in trig. A horizontal translation is no longer going to be called a horizontal translation. So yes, I use the words horizontal translation, vertical translation, but from now on out, we're going to switch those terms. So in transformation, if it moved left or right, it was a horizontal translation. If it's a trig function though, so a sine graph or a cosine graph, those are the only two that we're going to be transforming. We're no longer going to call it a horizontal translation, we're going to call it a horizontal phase shift. If your graph moves up or down, normally we call that a vertical translation. But in trig, we have to use the words vertical displacement. So what that means is if I gave you this, y is equal to sine x minus 30 degrees plus 5. Now, instead of saying, okay, we know this graph moves up 5 units. Instead of saying vertical translation 5 units up, you would say VD, vertical displacement 5 units up. Instead of saying horizontal translation 30 units, or sorry, 30 degrees right, you would say horizontal phase shift 30 degrees right. So let's see if we could do that in class example 2. So class example 2, we are only doing the phase shift and the vertical displacement. So if we, let's write our general form. So y is equal to the sine, actually I just need my a value, A sine B x minus c, and then plus d. Okay, horizontal phase shift is your left-right. That is your c parameter. Vertical displacement is your up-down. That is your d parameter. So in this graph here, y is equal to sine of x, there is an invisible 0 there. So there's no vertical displacement. Within my x, there's no bracket showing me it's moving left or right, so there's no phase shift. Okay, this one, Cole, is this a c parameter or a d parameter? C. So what you would say is you'd write down c is equal to pi over 4. Describing the horizontal phase shift, you would say horizontal phase shift pi over 4, you have to tell me the units for a phase shift. It's either degrees or radians. So horizontal phase shift, pi over 4 radians, because it's in pi's. And then tell me the direction. This guy would go to the right. There is no d value or displacement, so that would be 0. Morley, what would this be? Is that a C or a D? It is a D. So D is equal to 5, vertical displacement 5 units up. There is no C value for that one. This next one has a C value and a D value. So here's my C value in here. C is equal to negative 3 pi over 2. That would be a horizontal phase shift, 3 pi over 2 radians, and then the direction would be left. Dane, what's my D value for this one?
Pi.
Pi. Oh, not pi.
Negative pi.
Negative pi. D is equal to negative pi. That is a vertical displacement, pi units. The direction is down. That would be a C value. So that would be a horizontal phase shift. C units right. This one would be a vertical displacement, D units up. The last one is identical to what we just did. This would be a positive C value if it's negative in there. That's a horizontal phase shift, C units right. And then this is a plus D, which means it goes up, but it's called now vertical displacement. So instead of the word vertical translation, vertical displacement, what would that be? D units up. Okay. This page here has all of your notes on it, so everything that I just sort of explained is here. I don't even really think you need to read this. Most of this is already on your study sheet, right? So if the D, how to find the midline, is not there, make sure that's on your study sheet. So max plus min divided by 2. Does anybody remember what A is? If D is max plus min, Kelly, what would A be? That's the exact same thing as this, max plus min divided by 2. What would A be? It's not max plus min, it would be. Biology, no? Yeah. A is the max minus the min divided by 2. So what I'll often tell students, because that's not on your formula sheet, how to calculate A, how to calculate D, and we'll be doing that today when we're actually graphing. I tell students, just remember one of these two, like commit one in your brain, and then the other one is the opposite. So if you remember that D is max plus min divided by 2, A is max minus min. So it should be the opposite to get your A parameter. Okay, let's do class example 3. So what it says, it gives me the general form again of the sine and all the transformations and the cos and all the transformations. What it's going to say, to make this nice and simple for this one, A is 1 and B is 1. So that means there's going to be no vertical stretch, no horizontal stretch. We're just going to have to find the C parameter and the D parameter. So it wants me to do a cosine function with a horizontal phase shift 75 degrees right. So we would underline horizontal phase shift 75 degrees right, and then you'd say, is that a C or a D? So Logan, what would this be? C. Do you want me to write 75 degrees or negative 75 degrees? 75 degrees. Yeah. This is an X replacement. And in order to get 75 degrees, X is replaced with the opposite, X minus 75 degrees. They tell me that the graph, they want a cos graph. So that would be Y is equal to the cosine. If it is an X or a C parameter, that goes in the bracket. So in my bracket, I'm going to write X minus 75 degrees. And that is my transform function. It was just the cos graph moving 75 degrees to the right, and that's how I would illustrate that. The next one, they want it to be a sine function. So we're going to have Y is equal to the sine of X, and we're going to transform that. Horizontal phase shift, 3 pi over 5 radians left. Kylie, what would my C value be if it's 3 pi over 5 radians left? Negative 3 pi over 5. The replacement is X is replaced with X plus 3 pi over 5. Vertical displacement, 4 units up, that is going to be my D value. D is going to be 4. If we were doing the replacement, I mean, we're just going to write the actual answer because it's nice and easy. The replacement would be Y is replaced with, the Y will lie, so Y minus 4. Okay, see if you could figure out what your equation would be. It's a sine function. Y is equal to the sine of, I've got to get my phase shift in, horizontal phase shift. So that would be X plus 3 pi over 5. And then my vertical displacement is on the end, plus 4. And that would be the equation of your transformed graph after it underwent 2 transformations. Class example 4. Find the amplitude, period, horizontal phase shift, and vertical displacement of the graphs of the following functions. Let's write the general form of a sine graph. Y is equal to A sine, open your square bracket B, open your rounded bracket, X minus C. Close 2 brackets plus D. The one thing that I like about the parameters that they chose for sine, or sorry, for trig, it's just A, B, C, D, right? Before, with transformations, it was A, B, what was this? H, and what was this? Okay, so I like this because it's just like A, B, C, D. Just make sure you know what each one is. So A, we won't do both of these. Let's just do B. So let's do this one. And what I would do is, we know that, let's write our parameters. So this is my A parameter. A is negative 2/3. This is my B parameter. B is equal to 1/4. Here's my C parameter. Now C is not negative pi over 12, it is pi over 12. It's the opposite. And then here's your D parameter. D is equal to 3. Now that I've got the parameters, it wants me to talk about what's the amplitude. Let's do that first. So amplitude is A, and we said that A was negative 2/3. So let's write amplitude. I shouldn't actually say the amplitude is A because that's incorrect. What is the amplitude? The absolute value of A. The absolute value of negative 2/3 is 2/3. Okay, you can't have a negative height. So the amplitude is always going to be a positive number. The negative is just telling me that there's a reflection. There is a vertical reflection, is what the negative is telling me. But they're not asking that. They're just saying what's the amplitude.
Just a quick note to everybody for dismissal, students and staff, there will be no exiting the building by the stage door closest to the church parking lot. So there will be no access to that exit of the school.
Okay, so A is done. Now we have to do period. Period's the one that you gotta work for. That's the only one you have to work for. So period, period from the last lesson. Am I gonna do 2 pi divided by b, or am I gonna do 360 divided by b for this example? 2 pi, because they tell me, this tells me it's in radians. So the period is 2 pi divided by the absolute value of b. So just make sure you don't put a negative in. So that would be 2 pi divided by 1 over 4. That would be 2 pi times the reciprocal of 1 over 4 is 4 over 1. The period of this graph is 8 pi's. So now my period is done. Horizontal phase shift is my C parameter. So my C parameter is, we said it was pi over 12. So what that means is there's a horizontal phase shift, pi over 12. You must tell me the units. It's either degrees or radians for a phase shift. So pi over 12 radians, and then you tell me the direction. Because C is positive, it's going to the right. The last one is your D parameter, which is a vertical displacement. Vertical displacement, 3 units up. And that is describing everything. Now, remember in transformations, one of your long answer questions was I gave you an equation and I said, write out all the parameters, describe what's happening. You're gonna have a long answer, just like in transformations, but it's gonna be a trig question, like this. Except it won't be like class example 4 because the B value has been factored out of this. Like I gave you the B value factored out, but look at class example 5. The B value has not been factored out. So for class example 5, you might want to star this and write down factor out B value. And then this would be a perfect long answer exam question. We're gonna do exactly what we did in class example 4, except the only difference is we gotta factor out that B value. Okay, so let's do A, and let's factor out both A and B to make sure that we get this. So the B value is 3, right? So what you would do is you would say, okay, I'm gonna divide this by 3, and I'm gonna divide this by 3. Y is equal to 2 sine, factor out that B, and then have your second bracket. And that would be x plus pi over 3. And that now is minus 4. Then what you would do is above this, you would say, there's my A, there's my B. My C is going to be the opposite. It's not going to be pi over 3. It's going to be negative pi over 3, which is pi over 3 radians left. And my D is going to be 4 units down. Let's do this one, because this one's a bit harder to see. So you're factoring out, Adrian, what am I factoring out? What's my B value? 2. So divide that by 2 and divide this by 2. Y is equal to negative cos. Open your square bracket, factor out that B. Rounded bracket. X minus. I'm going to do this off the side. So pi over 2 divided by 2 is the same thing as pi over 2 times 1/2, which is pi over 4. So my C value, pi over 4, and then plus pi. Let's do the same thing. My A value is negative 1. My B value is 2. My C value is not negative pi over 4, it's pi over 4. And my D value is pi. Let's just do one of these. Let's do B again. Okay, so let's find the amplitude. So the amplitude of this graph is, John, what would the amplitude be? It is not negative. Just what number? 1. The amplitude is 1. You have to remember that. The amplitude is always the absolute value of A. That is on your, I promise you, is on your exam. Okay, the B value. The B value tells you about the period. So the formula for the B value, or for period, is 2 pi divided by B. The period would be 2 pi divided by 2. The period of this graph is pi. It's going to repeat itself every pi radians. Yes. Oh, yes, sorry. Did I do that in the previous example? I should say 8 pi radians. Yeah. You know what? It's interesting, Kelly. For this one, we have to say radians or degrees. Technically, for period, if you just said 8 pi, that's 8 pi radians. It's good to write the radians, though, right? To always write our units. So yeah, I'm going to write pi radians here. Because if it was degrees, I'd write 180 degrees. I wouldn't just write 180. The C value is the phase shift. So C is equal to pi over 4, not negative pi over 4, right? C is pi over 4. So that is a horizontal phase shift, pi over 4 radians, and then you tell me the direction, right. Last one is my D value, which is pi, vertical displacement, pi units up. So to see if you understand this, here would be your homework for this first part. No, because you're just moving on your y-axis up or down, right? Radians is like your x-axis. Your y-axis is just 1, 2, 3, 4. Yeah.